So we did all the stuff with segments. Now we're going to deal with angles. And this is what's going to make this harder, is because now, instead of just dealing with segments, problems that deal with segments, now you're going to deal with angles. And then as we go, we're going to add more and more stuff. All right? The first one here, if you remember the ruler postulate that we had before, the ruler postulate taught you how to do what? Use a ruler. Guess what the protractor postulate teaches you how to do? Use a protractor. Again, another not very useful. Hopefully you know how to use a protractor now. We've done it a few times this year. That's all this one tells you how to do. Main thing I'll say about this one, a couple of things. Make sure you line up the vertex with this center point. Line up one of the sides of the angle with the bottom line on your protractor. When I'm looking at this angle right here, how do I know whether that angle, how do I know if I use these, the 40, 50, or the 130 and the 140?
Common sense.
Common sense, sort of. Explain to me.
Because
What kind of angle is it?
acute.
That's an obtuse angle? That's an acute angle. So which numbers is it going to be?
The 40.
The 40 and the 50. So this one would measure how much?
45.
About 45. So make sure you know if it's an acute or an obtuse angle. Did I go too quick?
No, you're
Yes, no? Did I?
right. No, you're good.
Flow proofs, paragraph proofs, I don't know, is there anything to write? We're just going,
No, it's okay.
what I tell you about flow proofs and paragraph proofs?
We're not gonna use it.
We're not gonna use them, all right? We might deal with them a little bit here and there. I'm not gonna have you write them probably, unless everybody keeps complaining, then we'll start doing paragraph proofs. Does everybody understand that? Let's start doing paragraph proofs. Let's do that, right? Right, whole paragraphs? So then, let's quit complaining about it and try to learn. Angle addition postulate. You ever heard anything like this before? Angle addition postulate? Segment addition postulate. Same thing, only dealing with angles. Give you a second to fill in what you need to fill in there. I messed up. Fill this in too. This shouldn't just say, I probably just copied this off somebody. This shouldn't just say angle ABD. It should say, what's that M out in front stand for?
Angle.
That should say the measure of angle ABD plus the measure of angle CBD equals the measure of angle ABC. So this is in what form? This is an algebra form because we're doing addition. All right, now it's got the symbols with it still because we have to have the symbols, otherwise nobody's going to know what ABD is. All this says, all the angle addition postulate says, how many angles I have right now? One. I draw in another ray right here. 3 angles, right? If I know this angle's 10 degrees, this angle's 30 degrees, what do I know about this whole angle? 40 degrees. Just like the segment addition postulate said this segment plus this segment has to equal the whole thing. Same thing. This angle plus this angle has to equal the whole angle. Sort of common sense stuff. Again, anytime something's a postulate, that's the way it is. It's sort of a common sense statement. Cameron probably already knows, hey, if this is 10, this is 30, this whole thing's 40. It's not all that real complex. All right, so that's angle addition postulate. This angle plus this angle has to equal that whole thing. We don't use angle addition postulate near as much as we use segment addition postulate, but every now and then.
Good.
Some theorems. These theorems we do use quite often. On each of these, as we go through and do them, This is the second theorem. So there's actually like two separate theorems here. Either way, they both mean the same thing. I probably, if you use one or the other, I probably wouldn't count it wrong. So they're sort of interchangeable.
Supplementary.
Right.
Supplement, right.
As we go through and do these, whatever I have written, if not, I'll put it in. This is probably about as simplified as you can get it. Again, I think I said last time on some of the notes, that number there, 3.3, means absolutely nothing. Means in this book, it's called theorem 3.3. In some other book, it's probably called theorem 2.8. Some other book, it's called theorem 4.5. Who knows? Those numbers mean nothing. It's a theorem. They mean something to the book. They try to keep them in order, and that's all. And it's just a way to number something.
Do they have a real name? Should have a real name. A linear pair.
Right? That's probably what it is. It's probably called the linear pair theorem. So if you went on Google and said, "What's the linear pair theorem?" it'd probably pop these up.
Go ahead, I got it.
What?
Shows.
I'll have to watch this back.
So,
Yeah.
if we're given this picture, what do you know about these two angles?
They are.
They're adjacent to each other. Now, do you see adjacent up here anywhere?
No.
Because adjacent doesn't really help us. Adjacent just tells us that they're neighbors, right?
They're linear.
They're a
Linear pair.
linear pair. So we know that they're a linear pair. Once you know they're a linear pair, what can you tell me about them?
They're supplementary.
They're supplementary, or they add up to 180. Either one of them I would accept. All right? So if I give you this picture and it says, maybe it tells you this angle's 110. And it says, prove measure of angle ALZ is 70 degrees. Then somewhere through there, somewhere through our two-column proof, we'd say, we know that this angle and this angle, angle BLA and angle ALZ are supplementary because they form the linear pair, right? So we know that. Then we would say this angle plus this angle has to equal 180 because supplementary means that they add up to 180. And we'll do problems like this, and I'm going through this quickly. And then we would just do a little math and say, okay, now we know that the measure of that angle has to be 70 degrees.
Would you like put in X or something for the angle and like subtract?
That's sort of, yeah, except we're not gonna put in an X, we're gonna say.
Measure of angle A.
Right, so it's almost like what we just got into doing where we said AB plus BC has to equal AC. Except it's gonna be this angle plus this angle equals 180 in our two-column proof, and then we'll do the math from there. The next one, complement theorem. Again, the 3-4 means absolute nothing. Fill in what you need to fill in on this one. What's complementary mean? 90 degrees. If you don't remember that, you might want to fill it in there somewhere. Sort of.
Ebersole changed it.
You should have, like we did on that last one, you should have changed these into algebra form so that we could deal with them. But that's pretty close. So this one says if two non-common sides of two adjacent angles form a right angle, then they're complementary. We won't use this one very much. All right?
It looks a cube on yours, but it's obtuse on ours.
Yeah, it's probably
I bet there is
stretched it
a
out.
bisect.
So, what this is, all this is saying is, if you have this, and we know that this angle is a right angle, that's probably gonna be given to us, alright, we have this right angle here. And then it has something else going up through here, and we'll call this angle 1 and angle 2. Somewhere in our 2-column proof, we're gonna say angle 1 and angle 2 are what kind of angles? Complementary. And then we're gonna say, once we know that they're complementary, the measure of angle 1 plus the measure of angle 2 has to equal how much? 90 degrees. So that's what's gonna happen. Not so much using this theorem, it's not all that real important. The supplementary theorem, a little more important. Shelving. Maylin is installing shelves in her room. One of the brackets she chose for her shelf is shown. If the measure of angle 3 is 55 degrees, so I'm going to write that in right here. It's 55 degrees. Might do the same on your paper there. What is the measure of angle 4?
They're a linear pair.
They're a linear pair. Well, if they're a linear pair, what do I know about them? They add up to 180. So how can I find angle 4?
180 minus 55.
Somebody help me out.
125.
Everybody agree with Kellen?
Yeah.
So the measure of angle 4 is 125 degrees. Anybody have any idea, could we find angle 1?
Yes.
We could, I don't know, sometimes students come in here knowing this rule, sometimes they don't.
So that's a 90 degree angle.
We talked about it a little bit when we dealt with
They have
polygons.
to add up to 180, right?
What has to add up to 180?
Triangles.
3 angles of a triangle must add up to 180, so could we find angle 2?
So that's.
Yeah, so
angle
90
2's
plus
45.
So 90 plus 55, what's that give you? 145.
35.
So angle 2 is 35.
And the other one has to, those
How could we find angle 1 then?
180 minus 145.
180 minus
35.
35, what's that give you?
145.
So we could actually went a little farther because you have a little more knowledge about the triangle being 180 there. When building or repairing a bridge, construction workers build scaffolding to support themselves and the structure. In the scaffolding shown, ABC is a right angle. So ABC, that's this angle right here, is a right angle. So I'm going to put that big box right there. Make sure I know that that's a right angle. Measure of angle 1 is 40 degrees. What is the measure of angle 2? What do we know about angle 1 and angle 2?
Yeah, that's correct.
They add up to 90. They are complementary to each other, right?
So the other one's 50.
So what's the measure of angle 2? 50 degrees. I know none of this stuff you ever actually really use in the real world, but just a little quick story because we got to move along. My son last night's in college. He's in like his 17th year of college, I think. No, it's actually like his 5th, but it seems like 17 because I've been paying forever. He calls me last night and has a question. He changed his major, so he never asked me questions anymore. He used to be an engineering major, so he'd call and ask me questions about calculus and differential equations and all that stuff all the time. Now he changed it to construction management, some kind of setup. I have no idea. I don't ask questions, I just pay the bills. All right?
Okay.
It's better for dads that way, I think. It's less headache. So he calls me and asks me a question. He had a problem, and he's trying to explain it to me on the phone, and I send me a picture of it. And he's got this house, and it's not just this, but this is part of it. He's got this house, and it's got extra stuff on it. He's got to figure out all the square footage of the entire covering of the house. The surface area. All right? So he's got to figure out all of it. Well, he can do it all, you know, with the rectangles and everything, it's got other parts to the house added on over here and stuff, and all kinds of different stuff on it. And he's gotta figure it out for like 10 different things, cause you gotta put up insulation board, and you gotta put up plywood, and you gotta put up, this other kind of foam board.
Why you
and
go inside the house and just guess?
So on and so on.
You just
Yeah,
guess.
and just guess. That always really works with the people who are paying the bills, they just love it when people just guess and you're
Yep.
$3,000 over on and they could have bid less, and then they're out money.
My dad redid my room and he has 17 pieces of drywall left.
See, but that's fine for your dad, if your dad's working for some business and he has 17 pieces of drywall left. The person who owns that business isn't gonna be real happy that they paid for 17 extra pieces of drywall that are now gonna be worthless. So, when he had this, he couldn't figure out the area of this triangle, because they told him this distance was 28 feet. Well, that's the base of the triangle, but they didn't tell him the height. Alright, now thinking back to your algebra days last year, they did tell him this. That for every 4 rise, there was 12 run. The slope of the roof, in other words, then was 4 to 12.
So it's.
Alright.
It's 4 inches.
So, I couldn't figure it out at first when he was just describing it to me, it didn't make sense to me. But then, once he sent me the picture, and I figured it out. So, what he had to do is he had to figure out, you know, this area in here, because it has to be covered with that foam board and everything else also. So that he could add it into all these other areas. Now, what you had to do there was, on this, right here for this 28 feet, I split it in half, so half of it would be how much?
14.
And that would be a right angle right there, right? If I split it in half, I could make it a right angle if that's what I want it to be. And I just figured out, all right, if I started down here at this bottom corner, and I went up 4 inches, how much over should I go?
12 inches.
12 inches. Then I went up another 4 inches, how much over should I go? Up another 4, over 12. How many times should I do that?
14 times.
14 times, because 12 inches is a foot.
Foot.
So if I go up 12 inches, if I go over 12 inches, I'm actually going up 4 inches. Well, how many times am I gonna go up 4 inches?
14 times.
14. So 14 times 4 is 56. What's 56?
Inches. Is that side?
That's the height. That's how much I would go up. All right?
Inches.
And that's in inches, and we had to change it into feet. In feet, it ends up being 4 feet, 8 inches. So how tall is the gable here on this house? 4 feet, 8 inches. And now we can find the area of that, go through all that. But those are the things you gotta be able to do, and unlike what Michael's saying, what a lot of construction people do, that's why I love construction sites anytime they're close to my house, because everything's very, very expensive right now. And I get my sons, who both work on construction sites, and they bring home this stuff, and I insulate my barn with it. Because the people on the construction sites don't figure it up very correctly, and then they got extra. I said, yeah, bring all that home. So I got like 3/4 of my barn insulated now, and I didn't pay for none of it. Next one, some other theorems. Again, these theorems, you've seen these theorems before, except now they're dealing with what?
Angles.
Angles instead of segments. So all of these are the same. Reflexive property, again, when we do reflexive property, we're not gonna put angle in there. We're just gonna write anything equals itself. I don't care if it's an angle, a segment, whatever it is. For transitive property, we're probably not gonna use transitive property, so we'll mark it out again. What are you gonna write in place of transitive property?
Substitution.
Substitution property. Use substitution property instead of transitive property. It's just easier. Symmetric property, again, symmetric property just switches stuff around, not real difficult. Cameron, you gonna be able to stay in my universe way back here?
Yes.
I scared him, Cameron. Looked like you were off in the ozone layer somewhere or something. Is that the case?
He looked so confused.
You don't even know what it is.
Yeah, I do.
So explain it to me.
Okay, well, there's all these different layers in the atmosphere, and the ozone layer is the one with all the stuff in it.
It's the one with the
It's like
hole.
the stratosphere,
Yeah,
the
it's-
atmosphere.
but we
Okay,
fixed
so
it.
it's more fresh.
You have a hole in
Dude,
it.
I
It's
thought
not
it
much
was like,
pollution.
I remember we made that little thing in Miss Tubman's class, and it was like you had to like go through each of the.
Shows
Did
the
anyone
science
pay
class,
attention
make
in
sure,
that class?
The biggest
make
one
sure
is
you
the
put that,
stratosphere.
if they ask you what the ozone layer is on the
It has a bunch
test,
of
There's a
stuff
bunch
in
of
it.
stuff in it.
say, it's a layer with a bunch of stuff in it.
Am I wrong? It's the
I'll
one that
guarantee you, Mr. Bryant,
It's the one that everyone's mad about.
So
because
Isn't
all
it the
ozone
one that like
layers
protects us
going
from the
down.
heat rays,
Well, bring
and
that
sun
touch
rays,
to
and
the
because of pollution, it has a hole in it now, so it's like,
Yeah,
yeah,
the
we're
ozone layer has a hole in it
if
now.
you come in the morning, I already got, you make sure you get here early, cause I already
Is it
got some
earlier?
people
Is it
who
you? Alright.
are
Oh, the bell
coming.
rings?
Yeah.
Yeah.
For what?
Mr. Ebersole, will you let me act smart real quick?
Alright.
Isn't the ozone layer the one that like protects us from like the sun's rays and stuff, and everyone's upset because it has a hole in it because of the pollution?
Global warming.
Yeah.
Part of it.
Yeah, Dylan.
So reflexive property, anything equals itself, the other two again, use substitution instead of transitive property. We've talked about all those. All these properties work for all the algebra stuff that we did. We've written these properties down 3 times now. All the algebra stuff that we did works for segments, works for angles. When we get to triangles, guess what we're gonna write down again?
Wait,
Those
Same stuff.
Yeah, in geometry class, you deal with shapes.
Like,
Yeah, whenever I heard that you work with shapes, you hear it's easier than this.
so are we doing a rectangles too?
Yeah.
We'll probably just.
2 other theorems. These, I have the shortened form for you. Or this is one of them. Actually, there's 2 of them there. So this is one theorem. This top one here is one theorem. This is a different theorem. Probably if you mix these up, I probably won't throw a real big fit, as long as you get one of them. Go ahead. Don't tell me about it though. So what this is saying, we got some picture. I'm just gonna draw this and it's gonna be real quick. What do you know about angle 1 and angle 3?
They're supplementary.
They're supplementary. They add up to 180, right? So if those 2 angles are supplementary, and we know that because of the picture there, they're supplementary. And then I tell you, angle 2 is supplementary to angle 3.
Does that mean that angle 2 and angle 1 are the same?
Let's put some numbers in there. What could angle 1 be?
40.
If angle 1's 40 degrees, what's angle 3?
140.
Does everybody agree with him on that? Yes, no, maybe? Well, angle 3 we know is 140, and we know it's supplementary to angle 2. What's that tell us about angle 2?
40.
40. So what always has to be true about angle 1 and angle 2 here?
Equal.
They always got to be equal. And that's what these 2 theorems say. Angles supplementary to the same angle. So both these angles, 1 and 2, were supplementary to angle 3. 2 angles are supplementary both to angle 3 or the same angle, then those 2 angles must be the same, must be congruent.
Does the other one say like
Right.
if angle 3 and angle 4 are equal?
So this one says angles supplementary to congruent angles are congruent. So if I had angle 1 is supplementary to angle 2, angle 3, forget this picture now, don't look up here, I'm just using numbers now. Angle 3 is supplementary to angle 4. Angle 1 is congruent to angle 2, or not angle 2, angle 3, sorry.
And angle 2 and
If these two are congruent, what has to be true about those two?
they're congruent.
They have to be congruent. So the first one uses 3 of them and says they're supplementary to the same angle. The second one says that they're supplementary to 2 congruent angles. So 2 theorems there that we'll use in our 2-column proofs. Same thing on this one, except instead of dealing with supplementary, what's this one deal with? What's complementary mean? Adds up to 90 degrees. So say exactly the same thing. I'm not going to explain it all again, AJ. Just says the same thing, dealing with 90 degrees instead of 180 degrees. So look at this example that I have right here. We should have done the examples on the other one, I didn't do them. Angle 1 is complementary to angle 3. Angle 2 is complementary to angle 3. What's that tell you about angle 1 and angle 2? They are congruent. So angle 1 has to be congruent to angle 2. Next one says angle 1 is complementary to angle 3. Angle 2 is complementary to angle 4. 3 and 4 are congruent.
Then 1 and 2.
So angle 1 again has to be congruent to, ignore that.
So
Angle
on,
2.
on a proof, do we have to explain that, or can we literally just write angle 1 is congruent to angle 2, and then write if
You'd have to write one of those as your reasons.
and then, but we don't have to explain it.
No, you won't be, because remember in your 2-column proofs, you don't explain stuff, you just say, okay, I know this, and it was because it was given, was you're going down through here, let's say you get to 5, and you're gonna do something like this. You're gonna say angle 1 is congruent to angle 2, and your reason might be this little abbreviation that I have right here. Angles complementary to congruent angles are
Okay.
congruent. That would be your reason over here. So all these things all these theorems and stuff that we're writing down, those are the reasons that you put in your 2-column proofs. Next one, again, get rid of that. On this one, we wanted to shorten it up. This is what I'll shorten it up. Vert angles congruent. That one we're gonna use a lot. You might put an asterisk beside it. It's gonna get used a bunch. Vertical angles are congruent. Looking at our picture there, which angles are vertical angles?
4 and
4 and 1,
2 and 3.
2 and 3. Does everybody agree with that? So if I know angle 2 is 110 degrees, tell me another angle you know in that picture.
3.
Angle 3, what is it?
110 degrees.
110 degrees.
And 2 and 1 are a linear pair, so.
2 and 1 are a linear pair, so what is it?
That would be 70.
70 degrees.
The other one's like 70.
The other one's 70 degrees also. Now, we've done a bunch of these problems. I'm not going to do this example here, but could we use that? What do we know about angle 2 and angle 3 in our picture?
Is it the same picture?
Yeah.
They're equal.
So 10x minus 4 should equal 6 times x plus 2. Is that something we could solve to find the angles? We've done those problems in the past, right? And we're gonna do more of them as we go along. Let's do it while we got it up here. What do we do first to solve this? Distributed property, right, Ransom?
Yeah. 6x plus 12.
6x plus 12.
Or
No.
subtract 6.
Subtract 6x.
4x minus 4 equals 12.
4x minus 4 equals 12.
Add 4.
Add 4. 4x equals 16. Divide by,
4.
what's x equal?
4.
Now be careful what they ask us to find.
All angles.
Find all the angles, so we need to go back and plug in. This is probably the easiest place to plug in. What's 10 times 4?
40.
40 minus 4?
36.
So what's the measure of angle 30, or of angle 2?
36.
Very accurate.
36, right now. What's the measure of angle 3 then?
36 degrees.
How could we find the other two angles?
Just
Uh,
that one.
they're together.
Supplementary, subtract it from 180, I think that comes out to be 144, doesn't it?
That's so.
It's way off. Do we go by what the picture looks like?
No.
No, go by what the numbers tell you.
Did you get that?
Because a lot of times, who's drawing the picture?
No.
Yeah, you're probably right. Who's drawing the picture a lot of times?
Us.
You.
You. I don't think anybody else caught, Kellen, that you called them all done. Some other theorems and postulates that we use in our two-column proofs. This one gets used a lot. Now I'm going to shorten it down to this. Perpendicular lines form right angles. Anytime you see perpendicular lines, what you should think of, right angles. I don't want to hear anything out of you about not understanding stuff. You start focusing. You understand? This one we use some, and all it says is all right angles are congruent. Sort of a common sense thing. Not sure why it's a theorem, it probably should be a postulate. If you have a right angle, if you have two right angles, they're always going to be congruent to each other. And the other ones down through there, the other three, we won't use them as much. But those first two will get used quite often. Great, I know you had that put it down or something. Thank you, sir. Slip back up when you did it. This one says this. These last three sort of deal with this. If I draw a line here, and I draw another line here, and I tell you that they're perpendicular to each other, what do you know about both these angles?
Right.
They're both right angles. Both those angles, not only are they right angles, but we had a theorem a little while ago that said they have to be what to each other? Supplementary. They have to add up to 180, right?
Yeah.
And these say, if these two add up to 180 and we know that they're congruent to each other, the only way that that works out is if they're both
Right.
right angles, if they're both 90 degrees. And that's what sort of all three of these say. Write a two-column proof for this. Is this on your notes there?
Is there a bisect?
No, just the definition. So if something's being bisected, it's split into two congruent.
Like the midpoint thing?
Correct. Tell you what, I wanna skip this one. Wanna do it?
Well, it's good to have practice with it.
Yeah, that's true. Is this on there anywhere?
No.
Any of these.
Right, this I want you to actually write down.
Right now?
Yeah, find someplace, fill it in there.
No, just that one.
Oh,
All of them.
wait, so we're doing all, with right now all?
Yes, come.
Commonly used reasons. You don't have to write down any of them if you don't want, Kellen, I don't care.
What?
Luke, I would suggest that
Okay.
you write them down. I'm just tired of Kellen complaining about writing it
No, I was
down.
confused if he said, do you want us to write them all down, or just like a couple of them?
What do you think?
What?
He's got a big old list on the screen. Everybody's writing.
Branson, back to this world, man.
No? I'm trying to.
Put it where we were gonna write the 2-column proof right there. Why might I want you to write these down? I think I added these to it. Starting next time, we won't have any fill-in notes. We're gonna start writing all these notes. And all of you can blame the 2 young men sitting on the corners.
How was it?
Were they complaining? Were they complaining this entire time?
I was asking if you
No.
wanted us to write all those, because you had 2 of them marked, so I didn't know if you just wanted us to write those.
These are the reasons that you'll use in a lot of your 2-column proofs.
God bless.
You forgot the degrees sign on that 180 and all that.
Sorry. So when you go to do these 2-column proofs, and you're stuck on what a reason could be, what could you do?
Turn back notes.
Look back at your notes, look back at what this says. If as you're doing it, you have a picture maybe that you're dealing with that looks like this. Maybe your picture looks like this. Which of these down through here might we be using?
Vertical angles.
Vertical angles. Does everybody see that? That's what you need to look at. As soon as you see your picture, think about what could I be using in this? Might be dealing with vertical angles. What else? What other kind of angles do we have in this picture?
Linear pair.
Linear pairs. Nothing about linear pairs on here anywhere though. Supplementary angles. So probably like this one, that one maybe. You might be using angle addition, maybe. Alright, but probably not. It doesn't get used a whole lot. And then there's other things we could be using, but most definitely those couple there.
Red lines now.
And this mark here that looks like it's only doing those 2, it's actually those 3. Remember, we just used what?
That one.
That one. The other 2, other books use that. and some of them, some of the papers we do will say that, it means the same thing, all three of them mean the same thing.
So where, did we need to pick up this paper?
Yeah, we'll get ready to do it here in a second. That's what I'm trying to hurry and get to. That's what I wrote my notes. Sorry, you probably fit it. Let's see. You're the one that said it'd be good to have examples written down. That's what those next two are. On this, we're gonna think this through. This is a drag and drop. This is what you're gonna do on the EOC test at the end of the year. So if I come up here, or if I have you come up here, actually, we can't do it this way. We gotta do, we gotta end the show. This card. Whoa. I don't remember if we can do it this way or not. Gotta think about it. And we're gonna drag these things and drop them in their places. Now that one, is there any way that one should be in the statements column?
No.
No, that one should be in what?
Reason.
The reasons column somewhere. If you come up here and you drop and drag, please make sure, you see how I'm getting on one of the edge lines and dragging it? If I don't do that, then it's gonna screw up all my drop and drag stuff, and I gotta go back and try to fix it. Okay? So let's just think this through real quick. They tell us, I got this picture over here, I'm just redrawing that same picture that they have. That's C, we got A over here, B, C's there, D, E. What's the first given information tell us?
Segment AB is perpendicular with segment BD.
So what's that tell us?
That's a 90-degree angle.
So somewhere in our two-column proof, we're probably gonna say angle what? A, B, D is what kind of angle?
Right.
A right angle. Probably. I don't know. Does it say that somewhere in there? Oh yeah, right there it is. Then what?
Well, you have to find your.
What else does it give us?
ED. Segment ED is perpendicular with segment BD.
So what's that tell us about this whole angle? Right
It's
angle.
Right angle too.
So which angle's a right angle?
Angle
E, D, B is the right angles. We're probably gonna put that somewhere in our two-column proof. Alright, then it tells us what?
Angle ABC.
So that's A, B, C, A, B, C. That's this angle right here, isn't it?
Yep.
So that angle is what?
Congruent with angle EDC.
EDC, that's this angle right here.
Mr. Ebersole?
Yep.
Can't we literally do this in 2 steps? Because that says CDB is equals, or congruent to CDB, and anything equals itself.
Read it again.
Oh, those things are flipped. I am dyslexic.
So we're trying to prove, look at what Kellen's saying here. We're trying to prove that this angle is congruent to this angle, right? What do you know about these two angles? They're complementary. They add up to 90, right? What do you know about these two angles? They add up to 90. What do you know about these two?
Equals.
They're equal. Well, if these two are equal, these add up to 90 and these add up to 90, what has to be true about these two that we're trying to prove? Let's make up a number here. How much is this angle right here? 40 degrees. How much is this angle over here then?
40 degrees.
How much is this angle?
40 minus 90 is, yeah, 50.
How much is this angle?
50.
What ends up being true about those two angles?
That equals.
They're always equal to each other, aren't they? And that's what we're trying to prove, that those two angles are congruent to each other. What are we gonna put first on this? Anybody see the box that we should drag over there first?
AB, right? Wait. AB, no.
AB is.
The third one down,
perpendicular
yes.
to
Goes over towards.
See what I'm saying
Statements.
about? I can't even drag it right, see what it's doing? How do we know that?
It's given.
So everybody see how we're doing that? Get somebody else up here and direct. Let's go quick so you can fill it in there.
I forgot what I was doing.
You're not doing it?
I forgot what I was doing. Because you said I could do like, you could do it.
What do we do next?
You're
Well, just stand up here and
giving
we're
another
gonna do
given,
it together.
You're giving another given, right?
You can,
Okay,
even though that's not what we did.
yeah.
What did we say? If those two are perpendicular, what did we say?
They add up to 180, or,
Now, stop for a minute, Mike. All right, go ahead. He wants to do all the giving at once, which I don't like doing, but, all right. Now, just stay up there. What did the first given tell us? What'd you guys tell me over in our picture?
that it formed a right angle.
Formed a right angle. So what was a right angle? So drag it over. That's what we want to say next.
Other one.
How'd you know that that was a right angle? It's one of the rules that we had today.
Perpendicular lines form right angles.
Perpendicular lines form right angles. Anytime you see that upside down T, you know that you're forming what?
Right
A
angle.
right angle. Perpendicular lines form right angles. Now, since he did it that way, we also want to say the other one, right? What other angle had to be a right angle? Look at your picture.
Wait, they're back.
All right, so let's drag it over there. How do we know it was a right angle?
Same thing.
Same thing. Perpendicular lines form right angles. It'll be all right. Now, once we knew that both of them were right angles, then we went back to what? When we get stuck, where you look back at?
This.
That's true of the picture or the given information, right? Or is there other given information?
Angle ABC is congruent with angle EBC.
So maybe we use it next. See it anywhere?
Go back.
Yep. How do we know that?
Given.
It was given to us.
So this is what we do for the testing at the end of the year?
Yep. When they want you to write a 2-column proof, you have to drag and drop the stuff.
That's better, cause then you like, you know everything, it's just like,
Well,
it's in there.
until they start throwing in extra stuff, which I didn't have room to do on this, but. So now, stop for a second, look at what we had. We had to stick in numbers because you guys act like you were confused. What did we know about the two angles over there on the left-hand side?
Here.
Yeah. The two of them together, what? Complementary. Do we say anywhere in here that we have two angles that are complementary? Oh, yeah, there's a couple of them in there. So what two angles are complementary? ABC and, all right, so that's probably our next step.
And
CBD,
ABD,
You call it-
ABC, it's, that's a
So
very.
the,
that,
this one. and
Right.
that.
right.
That one goes there.
So put it next. How do we know that those were complementary?
They're right beside each other.
That's true, they're right beside each other,
If
but
two angles
and then
add up
if
to
you
a right, they are
490,
complementary.
look at what it says, Michael, in the boxes.
If two angles add up to a right.
Two angles add up to a right angle, then they have to be what to each other? Complementary. We're not messing up my box, are we?
Not trying to.
Now, if we said that about those first two angles, probably what are we gonna say next? Same thing about the other side, probably, right? What other two angles did we say were complementary?
CBD and CD.
Is that what we want? We don't want that they're congruent, we want that they are what?
Oh,
Complementary. How do we know that those two were complementary?
That one.
Is he right? Which one? Two angles add up to a right angle, then they have to be what? Complementary. And then once we knew that, look at what we have, stop for a second. Look at 6 and 7. Do you notice anything in both 6 and 7? Just like with the algebra stuff we were just doing. Anybody notice anything in both step 6 and step 7?
They're the same, except like,
Nobody notices anything.
They had the
They're
same reason.
both complementary to C, wait, no, never mind.
You're right, Luke.
yeah,
They're both complementary to what?
Signal.
CBD. So if they're both complementary to the same angle, what do we know about those first two angles, ABC and EDC?
Well, we already know.
They're
that-
complementary.
They have to be
Congruent.
congruent to each other.
well, that was given.
No, that's what we were trying to, you're doing it again.
What?
That's what we were trying to prove.
Prove,
Look,
okay,
I
yeah.
thought we were trying to prove that,
Hey, it is what we're
The
trying
proof
to
is
prove.
this.
yeah,
That's that.
We did it, boys.
look,
they're both equal to the same thing, so they have to be equal.
no, they're not equal to the same thing, they're complementary to the same. So you got these angles here are the same angle. Well, if this angle's complementary to that one, this one's complementary to that one, what's that tell you about these two angles? They have to be the same. And that's what we want next, is angle ABC. Oh, you were right, this one is messed up.
Yeah, we were told that ABC and EDC were equal, so. you
Oh, no,
flipped
no,
it.
okay,
You
I see.
flipped it.
Yeah, I flipped, so these two are equal. I'm doing what you were doing now, I read these wrong.
Okay, yeah.
So these two are equal, so what has to be true about those two? They have-